Okay, so chapter 6 is measurement. What in this chapter is a lot of formula. Okay, a lot of formulas. The first big topic is talking about length. Okay, it's talking about length. So we talk about length, area, surface area, and volume. Okay, we talk about those four things. Okay, we have units for length. We have units for surface area and area. And we have units for volume. We need to know all the conversions between the units. Okay, we need to know all the conversions between the units. For example, in length, we need to know three things. 1 kilometer equals to 1,000 meters, 1 meter equals to 100 centimeter, and 1 centimeter equals to 10 millimeter. That's the first three conversions you need to know. And some question may ask you, what is 1 kilometer equivalent to how many millimeter? You should be able to do that as well. Okay, so that's the first thing. And second is talk about the perimeter. Perimeter is the distance around the outside of a closed shape. Okay, basically adding all the things together. And there's a special one. Like perimeter is all the straight lines. Okay, all the line must be straight lines. All the straight line make this shape. It's called the perimeter. Another thing is called circumference. Okay, it's talking about circle. It's particularly talking about the circle. So it's the circumference. This is the distance around the circle. So it's 2 pi r or say pi d. R is the radius. Okay. We also have perimeter of a sector. It's like part of the circle. Okay, it's a proportion of a circle. It can be 3/4 of a circle or half of a circle. So the important thing of this is we will get some part of the circumference and we need to add 2 radius. So we have 2 radius and add part of the blue shape. So how we can interpret this formula? Okay, so the way you remember this is 2 pi r is the, okay, see the 2 pi r is here, is the circumference. Okay, it's this one, 2 pi r here, is the full circle. And I times this by theta over 360. Okay, for a circle, the inner angle is 360 degrees. Okay, and now the sector get angle of theta. Theta of over 330 is the proportion of the sector. Okay, is how, like 3/4? Is that 3/4 of the circle or 2/5 of the circle or 3/8 of the circle? It's talking about what's the proportion of the sector compared to the whole circle. And times the full circumference. It gives you the partial blue curve. Okay, it gives you the blue curve. And you add the 2r, that will give you the whole circumference, the whole perimeter, okay, the whole length. So that is the perimeter of a sector. So, okay, part B. Okay, that's what A talk about. In B, we talk about like a really easy thing is the pi sec. We know pi sec already, okay? A squared plus B squared equals to C squared. That's the first thing. Next thing is very important. I think we learned this in circle geometry, which is in chapter 2. Or maybe not. But like this is a really important like definition. So triangles in a circle. If there is an insubscribed triangle ABC in a circle O where AB is the diameter, then angle ACB must be 90 degrees. Oh, we have done this before. Okay, we have done this before. Because this angle is 180. Okay, this is the angle subtended by the same arc at the center. And this is the angle subtended by the same arc at the circumference. And the angle is like half of the relationship. The half of the relationship. Okay, here is 180. This is the arc subtended by those two angles and they are half relationship. Okay, the center one is twice as the circumference angle. So it's 90 degrees. That's what we learned in circle geometry. So that's exercise B is what we already learned this year and like long time ago, PASAC. Okay, in C we talk about area. Okay, what we have for area is this much. Okay, it's the unit conversion. Okay, unit conversion. So the easiest way to remember the square one is when you remember the length. Okay, when you remember the length units. Okay, for example, we have 1 meter equals to 100 centimeter. That's what we learned from exercise A. Now, if we talk about 1 meter square equals to how many centimeters square, if we want to know that, what we should do is, okay, 1 meter equals to 100 centimeter, and we want to square for it because there's 1 meter times 1 meter, so it's 100 centimeter times 100 centimeter, so it's 100 square centimeter square. Okay, so that's 1 meter square equals to 10 to the power 4 centimeter square. Okay, that's how we do it. We are not going to remember all of that. We're trying to calculate that by knowing the first unit in exercise A. Okay, that's the way we try to do that. Well, if you know 1 meter cube equals to how many centimeter cube, that will be 100. 1 meter equals to 100 centimeter, and then we cube that. Okay, that's how we find the unit converting. Okay, unit converting. Okay, so we have a couple of shapes. Okay, we have square, rectangle. Square is length times length. Rectangle, length times width. Triangle is a half base times height. Area of a parallelogram is the base times the height. Okay, base is B. Here is we don't have B. Okay, here is B. Can't see it. So this is B. Okay, this is B as well. So it's B times the height. And for trapezium, trapezium is a half A plus B, the two parallel lines add together, times the height and times the half. Okay, that's trapezium. And the next two, what we have to learn before is the rhombus and kite area. Okay, the rhombus and the kite area. So for a kite or a rhombus, it's a half x times y. Okay, it's a half x times y. X and y are the length of the two diagonals, so that is y. That is x. Okay, so it's the blue one times the green one and times by a half. Okay, half the two diagonals times together, and it's the same as the kite one. Okay, it's the same as the kite one. Okay. Area of a circle is pi r squared, we know that. And if we talk about the area of a sector, again, it's the same as the circumference, the perimeter of a sector. So pi r squared is the area of a whole circle. Okay, theta over 360 is the proportion. It's the proportion of the sector. So the proportion times the whole thing will give you the sector's area. That's how we remember this formula. Okay, so this is all the areas formula. Okay, I put everything down here. Okay, so the next one is the surface area. Okay, it's the surface area. We talk about cylinder. Okay, we talk about cylinder. So if we do cylinder is 2 circle plus a rectangle. Okay, plus a rectangle. So the formula will be 2 pi r squared plus 2 pi r times h. 2 pi r squared is the two circle, and h is this. 2 pi r is this length. Okay, 2 pi r is that length. So that's the total surface area. So for a core, we know it's a sector. We know it's a sector and a circle. Okay, it's a sector and a circle. So what we will know is, okay, here what we know is this is R. Okay, this is R. So what we know here is this is S. Okay, slant height S. And we know the radius is R. Okay, the surface area will be pi r squared, which is the circle, plus pi rs, which is the sector. Okay, pi rs is the sector, pi r squared is the circle. Okay, so those two add together will give you the total surface area of a cone. Okay, a cone looks like this. Okay, a cone looks like this. Okay, rectangular prism. It's basically like, oh, I shouldn't draw it here. Okay, that's a rectangular prism. Let's say that is length of A, that is length of B, and that is length of C. Okay, that is C. So it's about 6 face. So this is the easiest one. So we have 2AB plus AC plus BC. Okay, 2AB plus BC plus AC. So it's 6 face in total. This is easy. We're not going to talk about that. The next one is triangular prism. So triangular prism, I can do this. Okay, that's a triangular prism. I have height of h, and I must know the perimeter of this triangle, which is A, B, and C here. When you expand that, well, I also need to know the height. So what is the height? The height of this, let's say the height here is h. Okay, the height here is h. So when you expand that, that's a big rectangle. Okay, it's a big rectangle. So first, you will have 2 triangles. Okay, you have 2 triangles. Those 2 triangles will give you a half times A times H. And you have 2 of that times 2. That's the area of the 2 triangles. And okay, for this 3 rectangle, it can become a big rectangle here. Okay, with A, B, and C of the length, and H as the height. So therefore, this will be A, well, let's say that's H1. That's H1. So AH1 plus bracket A plus B plus C times H. Okay, times H is the big rectangle. A plus B plus C is the length. H is the width. And plus 2 triangle here. Okay, 2 triangle here. So that's the triangular prism surface area. Okay. All the formulas here. Okay, all the formulas here. And we have, okay, cylinder, core, pyramid. So for pyramid, we have okay, like that, like a square-based pyramid. This is a square-based pyramid, and I want to know the total surface area. So basically it's a square plus 4 times this triangle, okay, 4 triangle, 1 square base and 4 triangle. If I say this is L, okay, if this is L, and here will be L as well, okay, so this is the same. The base of the triangle is the same as the side as the square. And I know the height of this triangle, which is H. So this will give you L squared plus 4 times a half times L times H. Okay, that's the total surface area. Okay, that's the total surface area. And the one last thing is for sphere. Okay, one last thing is for sphere. I can't really sketch anything, I can't reason it for you, but just remember that's 4 pi r squared. So for a sphere, I will sketch like this. Okay, that's a sphere. That radius is r. Okay, that radius is r. So it's 4 pi r squared is the surface area. Okay, total surface area. So it's 4 pi r squared. Okay, that's just a little bit quick revision on everything you need to know from exercise A to exercise C, including all the formulas and all kinds of questions on the textbook. Okay, I'm not going to come back to this, but you can do the textbook question, and if you need any help, I can help you to do that. Okay, quickly come to volume. Okay, quickly come to volume. Okay, for volume, we have units. Okay, we have units. We have 2 kinds of units for volume. Okay, one type is metric units, and the other type is capacity units. Okay, what's the difference between that? You know that 1 meter cube is the units for volume. But when I ask you, how much water do you have in your water bottle? You won't really answer that there's 100 centimeter cube of the water in my water bottle. You will say 60 mils or 1 liter or like 1.5 liters. You answer like that. So when you talk about liquid, when you talk about the capacity for a bottle or jug or like anything, when you talk about capacity, we'll use another type of the units instead of kilometer cube, centimeter cube, meter cube, that kind of units. Okay, for the left-hand side, it's very easy to think about. You have kilometer cube, convert to meter cube. Okay, 1 kilometer equals to 1,000 meter. So it's 1,000 to the power of 3. That's 10 to the power of 9. Same as this one. 1 meter cube. Okay, 1 meter is 100 centimeter. And then you cube it. That will be 10 to the power of 6. Okay, 1 centimeter is same as 10 millimeter. And it's 10 to the power of 3. Then 1 centimeter cube is 10 to the power of 3 millimeter cube. That's how you convert between that. It's the same as when you teach you how to do the area one. Okay, so capacity units. There needs to be a link between the metric and capacity units. So the link will be this one. When you say 1 centimeter cube, that will be the same as 1 milliliter. Okay, when you say 1 centimeter cube, that will be 1 milliliter. Okay, so if you want to convert between those 2 things, you will use that to help you to link it. Okay, to help you to link it. Okay, next thing we want to know is 1 liter equals to how many millimeters? It's 1,000. You know that. Okay, 1 liter equals to 1,000 milliliter. Okay, and this one, 1 kiloliter. Okay, K means kilo. Okay, when we learn significant, we haven't learned significant figure this year. Okay, 1K. K is 10 to the power of 3. Okay, K is 10 to the power of 3 because it's like, say, kilo. So 1 times 10 to the power of 3 liters, which is 1,000 liters. So 1 kiloliter is 1,000 liters. And 1 megaliter. So what is megaliter? Mega is 10 to the power of 6. Is 10 to the power of 6. So 1 megaliter equals to 1 times 10 to the power of 6 liters. And again, that's 1 times 10 to the power of 3 times 10 to the power of 3 liters. Okay, this 10 to the power of 3 becomes a K. So that's 1,000 kiloliters. Okay, 1 megaliter is 1,000 kiloliter. 1 kiloliter is 1,000 liter. 1 liter is 1,000 milliliter. Okay, it's all 1,000 relationship. Mega, kiloliter, and milliliter. 4 things. Okay, 4 things. Okay, capital M equals to 10 to the power of 6 in the units. K means 10 to the power of 3. Lowercase m means 10 to the power of negative 3. Okay, it's 10 to the power of negative 3. That's for milli. Okay, that one. Milli, kilo, and mega. Okay, that's how we do the converting between the units. And let's do the example below here. Okay, example 1. 2 centimeter cube equals to how many milliliters cube? Okay, so we have 2 centimeter cube equals to 2 times what? Millimeter cube. 1 centimeter equals to 10 milliliter. And it's a cube. So I will do 10 to the power of 3. So that equals to 2,000 millimeter. Okay, 2,000 milliliter cube. That's how we do it. Next one. 500 millimeter, 2 centimeter. Millimeter is a smaller unit. Centimeter is a larger unit. Okay, you can't enlarge this number now. You need to make it smaller. So 500 millimeter cube equals to, okay, 500 times what? Centimeter cube. Again, 1 centimeter is 10 millimeter. So I will say 10 here. Because it's a cubic, I will go for -3. Okay, I will convert it between a smaller one to a larger unit. I will times 10 to the power of -3 here, not 10 to the power of 3. Okay, still a cubic, I will -3. So this equals 2.5 centimeter cube. It's 0.5 centimeter cube. Okay, next one. Next one, C. Meter cube to centimeter cube. So 2.1. I will times. Okay, meter to centimeter. A larger unit to a smaller unit. I will enlarge this number. Meter to centimeter is 100. And you cube that. You cube 100. That equals to, how many zeros you have? You have 6 zeros. So it's 1, 0, 1, 2, 3, 4, 5. Okay, 5 at the back. 2 centimeter cube. 100 to the power of 3 is 10 to the power of 6. You move your decimal 6 times. So it's 21 and 50 at the back. Sorry, change that. That's a cube. It's not a square. It's a cube here. That's a cube. Centimeter cube. Next question. It's a centimeter cube. Okay, for this one, centimeter cube. So centimeter is the metric units and liter is the capacity units. I can't do anything about it yet. So I will use the link to convert that. Okay, 1 centimeter cube is 1 milliliter. So this equals to this much milliliter. Okay, it's 210,000 milliliters. And now I want to convert into liters. It's a 1,000 relationship, but I convert between a small units to a larger one. It's 210 liters. Okay, it's 210 liters. Go back for 3 units. Okay, go back for 3 units. Because it's a smaller one I have. I need to decrease the number to make it to liters. Okay? Okay, this one. Liters to centimeter cube. Okay, liter is the capacity. Centimeter cube is the metric. So I need to use milliliter to connect them first. So liter will convert into milliliter first. Okay, 1 liter is 1,000 milliliter. So it's 1 milliliter. And that is 1 centimeter cube. Okay, I use the milliliter. Next one, milliliters to kiloliters. Okay, milliliter, okay, what we have is megaliter, kiloliter, liter, and milliliter. Okay, now I have milliliter. I need to reduce it by 3 zeros to make it to liter first. That is 3200 liters. And I want to make a kiloliter. I need to reduce by 3 decimal as well. That becomes a 3.2 kiloliter. Okay, move the decimal 3 units to the left. So it's 3.2 kiloliters. Okay, 3.2 kiloliter. Okay. Okay, next one. Next one is talk about the formula of a volume. So in this exercise, we particularly talk about the prism and the cylinder's volume. But we are not only restricted to those two shapes. I want to make this definition wider. Okay, we can use it like for more shape. For example, read this sentence. The volume for the uniform cross-section object. Okay, that is very important. What I'm interested in is whether this shape will have a uniform cross section. Okay, so if we want to know the volume of some shape objects, okay, what we're looking for is only one. Check one thing first. Is this object going to have a uniform cross sector? So uniform cross sector means you cut this object in a parallel way. Okay, you just cut it. You always have the same exactly shape, same identical shape. Okay. So for example, a cylinder. If you cut in this direction, you are not going to have a uniform cross sector. But if you cut it parallel to the circle, you will always have the circle. Okay, parallel to the circle. So it doesn't matter if you cut in one way, it's not uniform. If you cut it in another way, there's always if there's a one way, if you cut it and you always have the same cross sector, then this object is a uniform cross sector object. For example, the cylinder, if you cut it this way, okay, all the circle will be the same. Okay, you cut parallel. Okay, all the circle will be the same. For example, this one. Well, if you cut, say, this way, okay, cut this way, you're not going to have this uniform cross sector. But if you cut this way, then you will have the same the cross sector, which is this triangle here. Okay, let's look at some example which is not. For example, the pyramid. Okay, the pyramid. Doesn't matter how you cut it, you're not going to have a uniform cross sector because the cross sector will become smaller and smaller and smaller and smaller and reach a point in the end. Okay, reach a point in the end. Same as the core. Okay, it doesn't matter how you cut it. Yes, you always have circle, but they are not identical. The circle becomes smaller and smaller and smaller and smaller. Okay, so this is not uniform cross sector. Sphere is not. Okay, let's say this is not a circle. This is actually a sphere. Okay, like that. This is not uniform cross sector because when you cut it, the circle becomes smaller and smaller and smaller. So the point I want to make is, if you check this shape and this shape is a uniform cross sector object, then the formula is really easy to calculate the volume. The volume is just the area of the cross sector, which is the uniform cross sector, times the height. Okay, what is the height? The height will be like the base. Okay, this is a base, this is a top, the vertical distance between the base and the top. Okay, that is the height. For example, this shape is not straight. Okay, this shape is not straight. But there will be two, the top and the bottom. Okay, the top is here. Okay, on this plane, and this one is here. Okay, and the vertical distance between those two planes is the height of this object. Okay, is the height of this object. Okay, just be careful. The height of the object is not this. This is not the height. Okay, this is not the height because it's not straight. It must be the distance between the top and the bottom. That is the height. That is not a straight line, that is not a vertical line. Okay, so you are not going to have that. Okay, so as I said, if it's a uniform cross-sector object, we use the base times the height. Let's have a look at the cylinder. Okay, base times height. So the uniform cross sector will be this circle. Okay, will be the circle. So the area of the circle is pi times 6 squared. Okay, it's the circle pi r squared times 14. The height is 14 because in between the two circles, the height is 14. Okay, this is the two circle, the height is here. If you make it this way, okay, here is the 14, and that is the base. So base times height. Okay, if the question doesn't ask you to find 2 decimal places or 1 decimal places or whole number, do not find the approximation value. Okay, do not express pi as 3.14. Okay, do not express pi as 3.14 because the question asks you to put in decimals. Yes, you put that in decimals. Just show you this in the calculator. Okay, when you have your calculator, do not use your pi directly into 3.14. It's not the exact value. In your calculator, there's a button pi. Okay, use that button and then find the approximation if the question requires 2 decimals. Okay, I'll just show you. For example, this one. Pi r squared. Okay, pi is here. Okay, pi is here. Pi times 6 squared, which is 36, times height, which is 14. That is 504 pi. So you will write that as 504 pi. This is called the exact value. Okay, I know half of you don't know this. Okay, because I see entry exam paper and I see a lot of other tests as well. At least half of the class doesn't really know this. Okay, the question states that keep exact and everyone just puts 3.14 in the, it's the select entry of some class. Okay, I see the paper and about half of the students doesn't really keep this form. Okay, this is called the exact form. The pi is a number. Okay, you don't need to worry about it. Just keep it like that. If the question asks you 2 decimal places, do not do 3.14 times 36 times 14. What you should do is from this page and press Ctrl and Enter. That is the 2 decimal places you should write. Do not express 3.14 too early. Okay, forget about 3.14. Okay, you never use it really using a calculator. Use pi and press Enter. That will give you the most accurate value. Okay, most accurate value. This is the approximation value. If the question asks you 2 decimal places, that is the approximation value. So what you will write is 1583.64 meter cube. That's 2 dp. Okay, depends on what question is asking. Question asks exact 504 pi, exact. If asking 2 decimals, bottom one, 2 decimals. Okay, so, but do not use 3.14. Okay, sometimes it can have a really big difference. Okay, a really big difference by using pi and 3.14. Okay, for this shape, the height is given to you. Okay, the height is given to you. And you know here is 1.7, then here is 1.7 as well. And I tell you, the uniform cross sector is this triangle. Then I need to find the area of this triangle and times the height. Is base times height. So this is a right angle triangle. It's a half times 1.7 times 1.2. That's the area of the triangle. And I'll further times 2.4 on it. Okay, 2.4 on it. That's the area, that's the height. This formula can only be used by uniform cross-sector objects. Okay, if it's not a uniform cross-sector objects, you can't use this formula. Okay, in this exercise, yes, we can use that. Is the area times the height. Okay, area times the height. And that equals to 0.5 times 1.7 times 1.2 times 2.4, which is 2.448. Okay, 2.448 millimeter cube. Okay, millimeter cube. I'll do the last one. The last one, what shape you can see? Like the uniform cross sector must be this too. Okay, this whole face here. This is a composite shape. Okay, can you let me know what's the base composite of? What is it? A sector and what's that? It's not a, okay. What is a rhombus? This is a rhombus, no problem. Well, more specific, what is it? Can you see there's the angle sign here? Okay, can you see this angle? What angle is that? Right angle, right? Yeah, then here will be right angle as well. Okay, 4 lengths is the same, and you have right angle. What is that? It's a square. Okay, it's a square. It's actually a shape like this. It's a shape like that because when you draw to 3D dimension, you can't really see the original shape of it. This is something you need to be careful of. On your graph, not necessarily to look like exactly the same. Okay, it means this shape. It means this shape. But when you see it, it's like a rhombus and a sector. It's actually a quarter of the circle and a square. Okay, so a quarter of the circle and a square. Okay, that will make such a lot easier to do. Okay, because that's a sector, then this length will be the same as this one. This one is also the same as that one. The whole length is 4 here. Then each of that will be 2. Then the area of that will be 2 squared. Okay, that's 4 for the square. Plus a quarter times pi 2 squared, which is a quarter of the sector, a quarter of the circle, which gives me 4 plus pi. Okay, area equals to that. The volume equals to the area times the height, which is 6. Okay, which is 6. The height is 6 here, it's given to you. That is 24 plus 6 pi. Okay, centimeter cube. Centimeter cube. Alright, that's like 2 really easy examples and 1 a little bit trickier example. There will be more complex ones in your textbook. You can try those composite shape and figure out the volume. In this exercise, you must remember if the object has a uniform cross sector, we can calculate the volume by the area of the uniform cross sector times the height. That will give you the volume. Okay, we'll continue with that tomorrow.